So to answer the first challenge question, this is happening because of a property called electromagnetic induction. Let's assume this is our magnet here, and which pole is north and south doesn't really matter. So let's just say that the magnetic field created by the neodymium magnet that I dropped into the copper tube was shaped like this. So what's going to happen is this, as it falls down the tube, as it's on its way, it's moving, and you'll remember something called flux, and flux was the amount of magnetic field lines that was passing through a loop of wire. What flux will actually do is, well, nothing. But what does matter is change in flux. So if we focus on this section of the copper tube right here, as this magnet passes through that particular section of the copper tube, it is changing the amount of magnetic field lines that are passing through this. The result is an effect known as electromagnetic induction. And what electromagnetic induction does is it turns this small piece of the copper pipe into a wire. Now, it's not going to conduct up, it's not going to conduct down, it's going to conduct around in a loop, whether it be clockwise from our point of view or counterclockwise. Whether it's clockwise or counterclockwise has to deal with the direction of this magnetic field. That's not important. What is important, though, is that we have pieces of the copper pipe that are acting like a wire. And because they act like a wire, they begin to conduct electricity and they turn themselves into a tiny magnet. So we have one magnet here and another magnet as in a section of the pipe. So as this magnet falls and falls and falls, new and new sections of the copper pipe temporarily become magnets as the neodymium magnet itself passes by. On a free body diagram, what we're going to view is, of course, mg, gravity is pulling our neodymium magnet down, but since the copper pipe has begun to conduct current, albeit a small amount of current, it is still conducting current, it turned it into a magnet. And two magnets, when put in the presence of each other, will exert a force onto each other. So when I dropped the piece of metal that was not magnetic in nature, it fell through because it did not create current in the copper, and it did not turn the copper into a magnet, therefore the magnetic force did not exist. But when I dropped the copper, or dropped the magnet through the copper temporarily turns into a small magnet, exerting a magnetic force onto the magnet.